Hello class. I wanted to just say I hope everybody is doing well, and I do miss being in class. We're going to get started. I will be making videos for our lessons. So this is section 2.4 complex numbers, and just a quick review. The last time we were in class we went over example 1. We added the complex numbers, and then we also multiplied complex numbers. And in any situation where we have an I squared, we were able to replace it with a -1. And we also talked about how these two terms here are called conjugates. Basically, a conjugate is when you have a plus sign and then you have a negative minus sign. So they're opposites of each other. And so we're going to continue with section 2.4, working with conjugates. So a complex conjugates are pairs of complex numbers of the form a plus bi and a minus bi, whose product is a real number. To divide complex numbers, we multiply the numerator and the denominator by the complex conjugate denominator. Okay, so for example, if I had a plus bi divided by c plus di, to divide, we would multiply by the conjugate of the denominator. So the conjugate of c plus di is c minus di, and we multiply it to the numerator and the denominator. So what we can see now is after we multiply, we will be able to get a real number, just like we did in the previous example. Let me show you that. In example F, after we multiplied two conjugates together, it produces a real number. And so we would get a real number in the denominator, and then the numerator might contain imaginary numbers. So let's look at the first example. Here we have 2 plus I divided by 2 minus I. So we're going to multiply by the conjugate, which is 2 plus I. And so if I write this, we would have 2 plus I in the numerator times 2 plus I. And in the denominator, we have 2 minus I times 2 plus I. So if we multiply here, we're going to have 2 times 2 is 4. 2 times I is 2I. I times 2 is 2I. And I times I is I squared. Divided by 2 times 2 is 4. 2 times I is 2I. Negative I times 2 is negative 2I. Negative I times I is negative I squared. So notice here we have an I squared and an I squared. And so we're going to need to replace that with a -1 when we continue with our work here. So to simplify, we would get 4 plus 2I plus 2I is 4I. I squared we can replace with -1. And then the denominator we have 4. 2I minus 2I is 0. And then we have minus, replace the I squared with a -1. So we would have in the numerator 4 minus 1 would be 3. And 4 minus a -1 would be 5. So we can write this in standard form. So we would have 3/5 plus 4/5 I. And this would be our result. So let's try letter B. The conjugate here would be 1 plus 4i. And so if we multiply this, we would end up with 9 minus 19i times 1 plus 4i divided by 1 minus 4i times 1 plus 4i. So 9 times 1 is 9. 9 times 4 is 36i. And negative 19i times 1 is negative 19i. And negative 19i times 4i is negative 76i squared. And in the denominator, we would have 1 times 1 is 1. 1 times 4i is 4i. 4i times 1 is negative 4i. And negative 4i times 4i is negative 16i squared. So again, anywhere you see an I squared, we're going to replace that with a 1, negative 1. Okay. So let's simplify. So on the top, we're going to have 9. 36i minus 19i is going to be 17i. And then we have minus 76. I squared becomes negative 1 divided by 1. The 4i and the negative 4i becomes 0. And so we're left with negative 16. I squared is negative 1. So we end up with 9 plus 17i plus 76 divided by 1 plus 16. Simplify further. 9 plus 76 is 85 plus 17i divided by 17. So if we rewrite this, we're going to end up with 85 divided by 17 plus 17 divided by 17. 85 divided by 17 is 5. 17 divided by 17 is 1. So this gives us 5 plus I. A shortcut for the conjugates here, whenever you multiply conjugates, result that we're getting is c squared plus d squared. For example, in the previous example, we had whenever this is your A and this is your B, so the result is 2 squared, which gives me 4, and b squared, which gives me 9. So then we add these to get 13. Or you can just multiply as I did in these two examples. Okay, so let's move on to the next part. When a is a positive real number, the principal square root of negative a is defined as follows. So if we have a negative a, then we can rewrite this as negative 1 times a. And so far we know that negative 1 is also the same as I squared. So I can take the square root of I squared, which is going to be I, and then the square root of a is going to be inside. So from now on, whenever you see a negative a, this is equal to I square root of I. So for example, here we can take care of this negative inside of the square root. And so since I have a negative inside, I can replace that with replacing that negative with an I squared, which if you take the square root becomes I. So we would be left with I square root of 14 times, same for this one, we have a negative in here, so I can replace it with an I square root of 2. Okay, so that would be your first step, is to fix your radicals here so that they don't have any square roots. Step 2, you want to multiply. So to multiply radicals, well, first we can multiply these coefficients out here. So I times I is I squared. And to multiply radicals, we multiply the inside, which are the radicands. So 14 times 2 would be 28. Step 3, you want to simplify. So here we would have I squared times 28. So the 28, you want to be able to write it so that we can use a perfect square. So for example here, I can write 7 times 4, since 7 times 4 is 28. And this would give me I squared. We can take the square root of 4, which comes out as 2. And the square root of 7 would remain inside. And now, since I have an I squared, I can replace with a negative 1. So my final answer here would be negative 1 times 2 square root of 7. And that comes out to, we can just write it as negative 2 square root of 7. Okay, let's try example 3b. So here again, we can fix this negative 8 so that we don't have a negative in the square root. So this negative comes out as I. And the same for the negative 50. This would be square root of 50. So now, if we simplify, this is going to be I. The square root of 8 I can write as 4 times 2. So the 4 would come out as a 2. And the second 2 would remain inside. Now in order to add radicals, the radicand, the number inside, must be the same. So as you work with 50, to simplify 50, I want to see if I can have the same number, 2 times something, to give me 50. So that would be 25. The square root of 25 comes out as 5. And then the 2 remains inside. Since they have the same radicands, then we can add the coefficients in front. So we would have 5i plus 2i is 7i square root of 2. And last, we can look at letter C. So here we have negative 2 plus square root of negative 3 squared. We can rewrite this as follows. We can then work with the negatives inside. So this would be negative 2 plus I square root of 3 times negative 2 plus I square root of 3. Then we're going to multiply this out. So negative 2 times negative 2 is positive 4. Negative 2 times positive I square root of 3 is negative 2I square root of 3. And I square root of 3 times negative 2 is negative 2I square root of 3. And finally, I times I is going to give us I squared. Square root of 3 times square root of 3 is going to give us square root of 9. So we want to simplify. So I'm going to have 4 minus 2i square root of 3 minus 2i square root of 3 plus I squared. We can replace it with a negative, and the square root of 9 comes out as 3. Okay, so the square root of 9 comes out as 3, and I squared I'm going to replace with negative 1. So if we gather like terms, we end up with 4 minus 4i square root of 3 minus 3, and 4 minus 3 is 1 minus 4i square root of 3. So here we would have our answer as 1 minus 4i square root of 3. So let's turn the page to 65. And so now we would like to solve this quadratic equation. And remember, we can try to factor, but here it specifically says to use the quadratic formula. So the quadratic formula, as you recall, is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So our a in this situation is 8, the coefficient in front of x squared. Our b is 14, the coefficient in front of x, and our constant is 9. So if I substitute my values, b is 14, b squared is 14 squared minus 4 times a and times c divided by 2 times a. Okay, so we have negative 14 plus or minus the square root of 96 minus 4 times 8 times 9 will give us 288 divided by 16. (96) minus 288 gives me negative 92 divided by 16. The number in front of your square root here is called a determinant, and if it's negative, then we're going to end up with imaginary numbers. And so what that means is, since when we solve for a quadratic equation, the numbers that we're looking for are the solutions, or these values that we call zeros. But since it's an imaginary solution, that means that your graph might end up somewhere up here. So in other words, it's never going to cross the x-axis. So this is the situation for imaginary solutions. And that's going to happen when you have a negative in your determinant. So if we simplify, the negative will come out as an I, square root of 92, divided by 16. So we can rewrite 92 as 4 times 23 divided by 16. And so my answer comes out as negative 14 plus or minus, the square root of 4 is 2, square root of 23 divided by 16. And I can break this up as negative 14 divided by 16 plus or minus 2i square root of 23 divided by 16. Make sure you simplify. So negative 14/16 will become negative 7/8 plus I square root of 23 divided by 8. And so our answer is x equals negative 7/8 plus or minus I square root of 23 divided by 8. Okay, so please try example B, and the answer for example B is going to be x is equal to 1/3 plus or minus 2i. Again, if you don't get this answer, please send me a message so that I can work it out for you. And so this was section 2.4. In the next video, we'll continue with section 2.5.